4,000-acre lake in North Florida just emptied into its own floor. Not flooded, not polluted, drained. 12 billion gallons of water funneled through a single 28-foot sinkhole and vanished into the rock beneath the basin. The lake bed is cracked mud. A bobcat was photographed running across what used to be a boat ramp. So where does 12 billion gallons of water go when it drops through the bottom of a lake? Nobody was paying attention to Lake Jackson on Thanksgiving week of 2025. The lake sits in northern Leon County, Florida, 10 minutes from downtown Tallahassee, just off Interstate 10. Trophy largemouth bass, bluegill, gar, great blue herons, wood storks, osprey. The Florida Department of Environmental Protection classified it as an aquatic preserve. Birders come from across the southeast to watch waterfowl in the shallows. On a normal November evening, the lake stretches 6.2 square miles across its basin, surrounded by boat ramps and residential docks and cypress trees, standing knee-deep in warm brown water. The average depth is only about 6 feet, but the surface area is enormous. But the Big Bend region of Florida had already been in drought for months by Thanksgiving. Stormwater had stopped feeding the basin. Evaporation kept pulling what was left. And on the bottom of the lake, in a section called Porter's Sink, the sediment plug that normally seals the floor started to give way. By November 30th, Rob Diaz de Villegas, the ecology producer at WFSU Public Media, was standing at the lake at sunset. He documented water cascading down into Porter's Sink like a bathtub emptying through a pulled drain. Water was flowing across the exposed lake bed toward the sinkhole in braided channels, picking up speed as it funneled into the opening. By December 2nd, the basin around Porter's Sink sat fully exposed. 28 feet of cavernous sinkhole open to the sky, ringed by limestone and vegetation that had been underwater for years. A brief rainstorm refilled the area for less than 2 weeks. By January 6th, it was drained again. This time, the water did not come back. By March, the lake bed was sprouting vegetation across acres of dried mud, grasses pushing up through cracked sediment that had been at the bottom of a lake just 3 months earlier. By April 20th, when the Tallahassee Democrat sent a photographer out, the paper described the lake as almost completely dried up. 4,000 acres reduced to scattered shallow pools and long stretches of baked earth. And on May 4th of this year, 2 men, Matt Lisenby and Michael Sellers, climbed down into Porter's Sink to hunt for fossils. They were photographed by the Tallahassee Democrat standing on rocks that, on any normal year, would be under more than 20 feet of lake water, not next to the sinkhole, inside it. But the fossils are not the story. What those 2 men were standing inside is the entrance to a 19-mile underground river. And understanding where that river goes changes the scale of this entire situation. The same geology that created Lake Jackson is the reason it keeps draining. And the mechanism starts with what the lake is actually sitting on. Lake Jackson is a karst lake. It sits on top of dissolved limestone. Over millions of years, slightly acidic rainwater has been eating away at the bedrock beneath this part of Florida, dissolving it grain by grain, creating a honeycomb of cavities, fissures, and underground channels. The surface above this dissolved rock is full of depressions where the ground has sagged or collapsed. Those depressions fill with rainwater. That is how you get a karst lake. There are no rivers feeding Lake Jackson, no streams flowing in from higher ground, and no outlets carrying water away to the coast. It is a 42 square mile closed basin where rain collects in pools. The only water that leaves does so through evaporation, slow seepage through the sandy bottom, and 2 natural drain plugs in the floor. Lime Sink at the north end and Porter Sink at the south. When the plugs hold, you have a lake. When they fail, the lake has nowhere to go but down. The plug itself is not a valve or a cap. It is a mass of organic sediment, clay, and compacted debris that builds up inside the sinkhole opening over years of submersion. As long as the lake is full, the weight of the water column keeps it packed in place. It works the same way a finger pressed over the end of a straw holds liquid inside. Remove the pressure and the seal breaks. When the water table drops below a critical level, the hydraulic pressure holding the plug together weakens. The sediment loosens, water finds the gaps, and once the first channel opens through the plug, it widens fast. the lake starts feeding itself into the hole with increasing speed. Geologists estimate Porter Sink can drain up to 15 million gallons per day once the plug fails. Harley Means is the state geologist of Florida and the director of the Florida Geological Survey. He climbed down into Porter Sink himself during the 1999 drawdown. He compares Lake Jackson to a checking account. When more water comes in through rainfall than leaves through evaporation, seepage, and the sinkhole, the account stays positive and the lake rises. When the deposits stop, the account drains. The checking account comparison is useful, but it hides what is actually happening underground. The water draining into Porter Sink is not lost. It is being routed. In September of 2017, a research team led by Cian McGlynn of McGlynn Laboratories poured a fluorescent tracer dye into Porter Sink for the Wakulla Springs Alliance. The dye was the same bright green compound used to turn the Chicago River green on St. Patrick's Day, injected into the sinkhole by divers, while monitoring instruments were deployed at 23 sites across the region. The dye traveled south, 30.6 kilometers, about 19 miles, through the labyrinth of the Upper Floridan Aquifer, one of the most productive groundwater systems in the world. The rock down there is not solid. It is riddled with dissolved channels and conduits, some wide enough for cave divers to swim through, others no wider than a garden hose. The water moves through this maze at its own pace, governed by pressure gradients and the geometry of rock that dissolved over millions of years. 35 days later, a monitoring instrument at Wakulla Spring, one of the largest first magnitude springs on Earth, recorded a fluorescence spike. The dye had arrived. Average speed underground, less than half a mile in 24 hours. The study also detected dye at nearby Sally Ward Spring after 31 days. The underground flow splits into at least 2 exit points, both feeding into the Wakulla River system. Lake Jackson is not disappearing. It is moving, slowly, invisibly, under 19 miles of pine forest and karst plain, to resurface at one of the most famous springs in the world. Think about that for a second. Every gallon draining through Porter Sink right now is beginning a 35-day journey through pitch-black limestone caverns with no sunlight and almost no air pockets. Just water pressing through dissolved rock at less than half a mile per day, following paths carved by water that made the same trip thousands of years ago. The karst plain between Lake Jackson and Wakulla Spring has been explored by cave divers who have mapped miles of submerged passages through the limestone. That is the highway Lake Jackson is draining into. The underground plumbing explains where the water goes. It does not explain why the water is leaving so much faster than it used to. And this is the part of the Lake Jackson story that the headlines are missing. For most of the last 200 years, Lake Jackson drained roughly once every 20 years. The native Muskogee name for the lake was Oke-Heepki, which translates to disappearing waters. Major drawdowns were documented in 1829, 1907, 1932, 1957, and 1982. 5 drains in 153 years. A pattern as steady as a slow geological clock, regular enough that each generation around Tallahassee grew up expecting one major drain event in their lifetime. This is where the story takes a turn nobody expected. Since the late 1990s, the lake has drained partially or fully in 1999, 2001, 2006, 2012, 2021, and now 2025. 6 drains in 26 years. The interval has collapsed from 2 decades to a handful of years. The Florida Department of Environmental Protection documented that Porter Sink drained fully 11 times just between June of 2021 and late 2025. That is not a typo. 11 full drains in 4 years, in a system that historically drained once per generation. From 1829 to 1982, the average gap between major drains was about 30 years. From 1982 to 2025, the average gap is roughly 4 years. And the most recent cluster, 2021 to 2025, is averaging less than 1 year between events. The pattern is not leveling off. It is steepening. The question nobody has publicly answered is why. The simplest explanation is drought. Less rainfall means less water pressure in the basin, which means the sediment plugs lose the hydraulic force holding them in place. But that does not fully explain an acceleration this dramatic. Florida has had droughts before, severe ones, and none of them triggered multi-year cascading drain events at Lake Jackson. Whatever is driving the acceleration now is something different. and no published study has isolated the cause. If the acceleration had stopped 5 years ago, this would be a very different story. The 2025 cycle is colliding head-on with the worst drought in Tallahassee's recorded history. In February of 2026, the Northwest Florida Water Management District issued a water shortage warning. It is the third one in the district's entire history. The previous two were in 2000 and 2007. The district-wide rainfall deficit over the prior 120 days was 6.2 inches below normal. Groundwater levels were declining and showed no sign of recovery. All 5 Florida water management districts are now under simultaneous water shortage warnings for the first time. The entire state is running a deficit. Lake Jackson did not just disappear on its own. It was set up to disappear by the longest dry stretch in Tallahassee's recorded history, falling on a basin that already had a drain in the floor. A drain that is now opening more often than it has in at least 2 centuries of observation. If you are learning something from this, hit subscribe. I cover geography and earth science stories like this every week. So, the drought explains why the lake drained this time. What it does not explain is what happens next. The impacts begin at the lake's edge. At Fox Drive Landing, the boat ramp ends in mud. Birders who used to track waterfowl across open water now track shorebirds, picking through cracked sediment. Fish populations, bluegill, largemouth bass, and gar, have compressed into a handful of remaining deeper pools at Church Cove and McGinnis Arm. With an average depth of only 6 feet at full pool, the fish have almost nowhere to go once the sinkhole opens. The Florida Fish and Wildlife Conservation Commission says the eventual refill will benefit the lake. A drawdown is a natural reset. It kills invasive vegetation, exposes accumulated sediment to the air, where it oxidizes and compacts back toward clean sand bottom, and rebuilds the lake bed from scratch. When the water comes back, the fishing is usually better than before. But that long view is harder to sell to the homeowners watching 12 billion gallons drain from their property lines. The lake is not just a fishery and a bird habitat. It is a real estate asset and the defining feature of an entire residential corridor north of Tallahassee. When the lake goes dry, property values wobble. Docks become expensive structures sitting on dirt. Boat ramps lead to nothing. 12 miles south, the same drought signature is visible at Cascade Lake near Tallahassee International Airport. Cypress trunks that were submerged a year ago now stand fully exposed, marked by a sharp band of pale bark that climbs 10 feet up from the base. Below the pale line, dark staining from years of submersion. Above it, the bark that lived in air. And further out from the lake, the systemic stakes get much larger. The Floridan Aquifer, the underground system that Lake Jackson is now feeding through Porter Sink, provides the drinking water for nearly 400,000 people in the Tallahassee metropolitan area. The aquifer also feeds Wakulla Spring, which is already on Florida's impaired waters list for nutrient loading and water quality degradation. The dye trace confirmed that Lake Jackson is one of the sources feeding those problems. Pollutants, agricultural runoff, and urban stormwater that collect in Lake Jackson do not stay in the lake when it drains. They follow the water underground. Every contaminant in that 12 billion gallons is now on its way to the same springs and wells that people drink from. In karst systems, the underground channels act more like pipes than filters. What drains from Lake Jackson reaches Wakulla Spring in just over a month. This is not just about one lake anymore. The Floridan Aquifer underlies virtually the entire state of Florida and supplies drinking water for millions of people. Right now, every water management district in the state is signaling that the balance between recharge and withdrawal is tipping the wrong way. Lake Jackson is one data point, but it is a visible 4,000-acre data point that shows you in real time what an aquifer under stress looks like from above. Most people never heard about this next part. There is a question buried in the Florida Geological Survey data that nobody has publicly answered yet. If a lake that used to disappear once every 20 years now disappears every few years, what does that say about everything else built on top of the Floridan Aquifer? Every home foundation, every road, every water well, every retention pond in karst country sits on the same dissolved limestone that Lake Jackson sits on. The difference is that Lake Jackson is a natural indicator. It shows you when the pressure in the aquifer drops, when the sediment plugs lose their grip. The rest of the built environment does not come with that warning system. Sinkholes open under houses in Florida. They swallow cars and collapse sections of road. Every one of those events is governed by the same physics that drains Lake Jackson. When aquifer levels drop, the voids in the rock lose the hydraulic support that keeps them from collapsing. The surface becomes more fragile. Lake Jackson is telling you what the aquifer is doing. The question is whether anyone is reading the signal. The National Weather Service Forecast Office in Tallahassee says a stalled cold front could deliver 1 to 3 inches of rain this week. It is welcome, but researchers say it is almost certainly not enough. Lake Jackson needs consistent 3 to 6 inch rainstorms to rebuild the water column. Half-inch showers evaporate before the next one arrives. The Atlantic hurricane season opens on June 1st. A single tropical system tracking across the Big Bend could refill the lake in days. That has happened before. The sediment plug resealed under the new water column's weight, and the cycle completed itself. Lake fills, plug holds, years pass, drought returns, plug fails, lake drains, water moves underground, and the clock resets. Except the clock is not resetting the way it used to. The intervals between drains are shortening, and nobody has determined whether repeated rapid cycling affects the integrity of the sediment plug each time it reforms. Without a tropical system, the basin is likely to remain exposed through the summer, with vegetation growing across the bottom and the Floridan aquifer continuing to absorb whatever trickles down. There is one more variable nobody can predict. Porter Sink does not stay open forever. Sediment will eventually plug it again, the same way it has plugged itself for at least 2 centuries. The plug rebuilds naturally as material washes into the opening and compacts under the weight of water above it, but nobody can forecast when. It could be weeks. It could be a year. The real question is not when the sinkhole closes. It is why it keeps opening faster. 3 questions hang over the basin tonight. How long will Lake Jackson stay gone? Why is the drain cycle accelerating after nearly 2 centuries of predictability? And what does it mean that one of the largest springs in the world is now receiving 35 days worth of an entire Florida lake, arriving through the limestone one slow pulse at a time? The water that filled the lake on Thanksgiving morning is right now somewhere beneath the pine flats between Tallahassee and Wakulla County, moving at less than a kilometer a day in the dark toward the surface. Porter Sink is still draining. The aquifer is still absorbing. And somewhere south of the lake, deep in the limestone, the next 40,000 acre-feet of Lake Jackson is on its way to Wakulla Spring. If you want to see another story about water systems under stress, that video is on screen now.